Okay, you kick this ball, it flies up like this. It travels some distance, x. It has some initial velocity, v0. It has some maximum height, y. Okay, now, is there anything else that you can tell me about how that ball behaves? Let's say at the top of its trajectory, at the very top of the flight. Colin, what is the vertical velocity at the very top of the flight? You're not sure. Watch. What is the vertical velocity of any projectile motion, or any projectile on this planet at the top of its flight? Okay, so watch again. The vertical velocity. Again. Vertical velocity at the very top. We'll live with. Yes. You got this.
I'm not sure how accurate.
Okay, how would you describe the motion of this? What does it do at the top? Okay, very. Stay what? I'm sorry? Stay still. What is the velocity of any object that stays still? Aha. Are we clear about this? Right, at the top of an object's trajectory, its velocity vertically is 0. So we know up here, Vy final is 0. Does that mean it's not moving? No. What velocity does it have?
X.
Yeah, right, it has Vx. Does Vx change over the entire trip? No, not at all. Okay, it's good. Saw a couple people saw Otis shaking his head. No, it does not change. I think you should be right. Never mind. Okay, so if we know that at the top the vertical velocity is 0, then we can do some things because, well, let's say I don't know what I'm doing. So what do I do? Projectile motion problem? I don't know what I'm doing. What do I do? Exactly, write down the two equations. See how this works? Just write them down because that's what leads you to go where you're gonna go. So x is vxt, y is vyt plus 1/2 a t squared. Okay, now let's break this down into an entirely different problem. Okay, and I want you to do this on your homework paper somewhere. Let's see. Okay. Some object flies from some initial velocity straight up in the air, and of course at some point it's going to stop, so some final velocity of 0. And it takes 0.833 seconds to get there. Tell me its initial velocity. Go. Talk to the people next to you, figure it out. Or if you're antisocial but intelligent, figure it out yourself. If you're antisocial but not intelligent, I'm sorry, you need to break through that barrier and talk to someone who can help you. You're finding the initial velocity. Because what is the only thing on that diagram you don't know?
You know that when it goes in.
Initial velocity.
How it decides the velocity too. And how do you get position?
You need a very important piece of information, which I left off on purpose.
The distance.
What is the important piece of information that's hidden? Or whatever, I guess you could use 9.8 or something if you want. Okay, in order to stop burning time, if you want to keep doing it yourself, just don't look up here. So I'm just going to say that's my givens, that's my hiddens, that's my asked for. Oops, just kidding. Wrong one. Yes. Okay, I'm gonna say this is around 8 seconds. Oh, just kidding. Oh, no, just kidding. Sorry, 8 meters per second. That's V initial. Sheesh. So all I did was just use the things. And I mean, even, like, I've been doing this for years, but I just went through the equations. And I thought one equation popped up in my head, and when I went through it, I was like, oh crap, I don't have distance, so erase it. And then I went through the next equation, erase it. Until I got to the equation that gave me what I needed, boom, there it is. So that is my initial vertical velocity, yeah.
When you make acceleration negative, how do you get positive at the end?
Oh, because this, like, if, oh, yeah, okay, that's one. Because I'm having mental retardation problems. All right, it's this one that's 0, right? V final was 0. I put 0 in the wrong place. So then I get V0 is negative AT. Thanks, Helen, sorry. Everybody see that? I mean, if I just use this, but whatever, panic mode, I plugged in the wrong direction, the wrong place. But that's great, I love that. It's like, wait a minute, you did something wrong, good job. Any other questions? Okay, so I have this. Now remember, that means Vy, right? I asked you this, remember there's V0 here, there's Vy here, and there's Vx there, yes? What was Vy equal to, if this is theta? V0 sine theta, right? So Vy is V0 sine theta. So, and this is, this is Vy. So if, and this is actually Vy, this is like Vy, Vy initial, there you go. Yeah, V0, this V0 is Vy initial. So this thing, when it took off, had 8 meters per second vertical velocity. So if you know that this is 8, and you know this to be 22 degrees, find V. Find this one, find V0. So do that now. Okay, hopefully you use this right here. And you said V0 is going to be equal to Vy over sine theta. So the original velocity, not the vertical, not the horizontal, but the velocity at an angle of 22, should be something like 8 over sine of 22. And what do you get when you do that? Let's see. Jenny, what'd you get?
Right now, I have 41.
What was that?
I got 21.35.
21 point, let's just say 21.4. Did you get around 21 meters per second? Okay, and that's this, 21.4 meters per second. So that is our original velocity. So how did we do that? Let me go again. And what you had to do was first look only in the y dimension. First, look only in the y dimension. And when you did that, then your initial velocity in the y, that's what we're looking for. We have the time, we have the acceleration, so we And we know the final velocity in the y. That was 0. So then when we did that, we got v initial in the y to be 8 meters per second, approximately. And then we said, from like that original velocity, right, if this is 8 meters per second, then that should be v0. So then we know that v0 will be 8 meters per second over sine of 22 degrees. And that's how we get our 21.4. And all that stuff is in the recording, so you don't have to worry about it. Okay? Now, at the very top, Colin has already told us that the vertical velocity at the top was what, Colin? 0. So what is the only kind of velocity that this has at the top? Yeah, horizontal or x. So we know the total, right? We know that the total is 21.4. So what is this? Oh, look, I was actually kind of close, which is funny. This was 21.4 meters per second. So then, if it was 21.4, we know that this was around 8 meters per second. What's this one? Everyone do it now. And Jonathan, there he is. Jonathan, give me your answer when you do it. Give me a cold too. All right, what do you got, John? 19.8? Do you agree? How did you do that? Oh, okay. Could have used Pythagorean theorem. Could have used this right here. Or you just do 21.4 times the sine of 22 degrees. I mean, cosine of 22 degrees. Right? And everything's done. Could you plug that in? What do you get?
I messed up, I did some.
Okay. What's 21.4 times cosine of 22? Is it 19.8? Okay, cool. Very good. So then, if the vertical velocity, as Colin told us, was 0, and the horizontal velocity is 19.8, do you see that the velocity at the top is just 19.8 meters per second? Okay, and then finally, we need the x distance. Now, so these first two, actually, like, these weren't even like two-dimensional motion problems, right? Does that make sense? This was like one-dimensional motion, just throw something in the air. So, but the second part, or the third part, whatever, this x part, that's where this all comes into play. We know that the time, and then now I'll do this probably, what I'm gonna do is this the easy way. We know that the time it took to get to the top was 0.833 seconds, correct? What goes up must come down. So guess what the total time is in the air? Yeah, 1.67, right? Oh, goodness, yeah, that's right. I think that's right. Does that make sense? Just double this is what I'm saying. Because what slowed you down to get you, to make you stop at the top? Gravity, right? So what brings you back down from the top? Okay. So then now I know the total time, right? Here's an interesting issue. What is, for the total travel, what is the displacement? Okay. Melissa's not here. Lisa, what is the displacement of the ball vertically? Okay, well, let me ask you this. Can you jump in the air? Okay. When you finish jumping, how far are you from where you started? In the y dimension only. So, have you ever, you've jumped in the air before? Where did you end up? Which means your displacement is what? 0. Does everyone see this? If you go up, Eduardo has never kicked a ball that never came down. Well, maybe it was stuck in a tree or something. Land on somebody's roof. But right, you get the idea. You kick a ball, it goes up, it's going to come back down. So the delta y, another piece of hidden information, is the delta y is going to be 0. Well, like we don't even need that. Sorry, I got ahead of myself. Look, we want x, yes? Do we know vx?
Yes.
Yeah. Do we know t?
Yes.
So 19.8 meters per second times 1.67 seconds. So this is going to be around, that's around 20. So this is going to be around, I don't know, like 34, 33, around 30 meters. So it's about 30 meters. Okay, I think it'd be like 35 or something, but whatever. There you go.